with respect to Taylor series. So you have a function like fx1, x1, 2. In the previous class also we started like this. You just forget about n number of variables. Just take into account only 2 variables. So you have x1 and x2. So how would you write? You will write z1 naught is nothing but the first one. Let me just go to this. The z1 naught. Sorry. Yeah, the z1 naught is nothing but the function value at initial point. So it is simple, as simple as that. You are putting the initial values in the function plus the partial derivative with respect to x1 multiplied by delta x1 plus the partial derivative with respect to x2 multiplied by delta x2 plus partial derivative with respect to xn and delta x. That's how you do it. Okay. Obviously, our objective is to represent it by an equivalent linear model. So for that, what we are doing, we are trying to rearrange the content in the next third one by certain the coefficients, which we call it as Jacobian coefficient, Jacobians. So Jacobians are nothing but the partial derivatives evaluated at initial values. Okay. So J11 is nothing but the partial derivative evaluated at initial positions around which you are doing the linearization. So very simple. I mean, just by looking at these equations, it may look little different or little difficult, but it's very easy. You just have to have a function, okay? A function value, and you know the variables, how much variable it is. So if a function is like x1 square plus x2 square, so it's have two variables, x1, x2. If a function is like x1 x square plus x2 square plus x3 square plus x, it's have 4 variables. So that's how you decide it, the non-linear function and the variable, associated variable. Okay. So I hope it is not difficult as such, just by looking at this. So Z1 is equal to Z1 naught plus J11 delta X1, J12 delta X2, and J1n. So obviously delta X1, delta X2, delta Xn, you can separate it out in order to write a matrix notation, and that's how you write it. Z11, Z1, Z2, Zn up to Zm is equal to Z1 naught, Z2 naught, Zm naught plus J11, J12, J1n, J12. Obviously, it is wrong here. It is written. It should be 21, J21, J22, J2n, and similarly Jm, M1, M2, M3, like that. So this is a correction which we need to understand. It is J21, and this is not plus. It is multiplication. So 2 correction in the slide. Just repeat it again. There are 2 corrections in the slide. It should be J21 and it should be multiplication. So that's how you write it. Z is equal to Z0 plus J into delta X. So obviously you could fill the dimensions of the deliverables. So one is Z is of M cross 1. Obviously Z0 would also be of M cross 1, but J would become M cross N as your delta X is of N cross 1. So error would be delta Z. Obviously dz would be Z minus Z0, which would be equivalent to JDX. So as error in Z and X are relatively very small compared with the absolute magnitude of Z and X, we may approximate the infinitesimal differential dz and dx by corresponding finite errors sigma z or ez and ex. Let me just also very clearly tell you that the z minus z0 is very small. The reason is very simple. The function initial value is chosen such that, okay, that it would look like that these are the final solutions. So you may not choose, obviously if you do not have any idea, you can go ahead with 0, 0, 0, 0. But obviously the objective of this approximation is that you should have the final value in the mind, that around that you could choose your initial value, because it would take less time to converge to the solution rather than you are just having a lot more deviation from the expected value. So that will come by your experience. But anyhow, is there any doubt in this? Let us just discuss, then move ahead. Okay, so we are moving towards the law of propagation of known non-random errors, or you could also guess, or assumed known. Okay, So by non-random errors, what we mean? We mean small systematic type errors, which are surely existing in the observation, but are at unmodeled and cannot be calculated via using mathematical form. So it is the, as I've told you, that in some previous classes, that there would be some certain undetected systematic errors that would be there in the system, and probably you would have missed them, but they would be traveling into the system and you would be treating them as a random errors, but it is not the case. They are small systematic errors, and this the sentence talks about the same, that you have the small systematic errors which are surely existing in the system. Okay, so this kind of error should be considered in our computation of precision of the desired quantities, and we are computing once we have a reasonable information on the magnitudes of these. Okay, so in some cases we are able to have a reasonable idea, assumptions, hypothesis on its magnitude, and in some cases we do not have any such idea at all. So for that you have a function, you know the variables, and so we know how the variables are there and how we need to compute the so-called the function for that. So law of propagation of non-systematic error is given by, obviously it is summation of all 1 to n, the partial derivative with respect to individual observation, and obviously the deviation. So del Li bar is nothing but the non-random systematic error in ith observation, and del x hat, this x hat is nothing but, del x hat is nothing but corresponding non-random systematic error in the parameter. So it is basically relating the parameter with the observation. Obviously when we talk about the first function, if you talk about this equation, this one, the x hat is equal to function, so this talks about the how the parameters is connected with the observations. Obviously since you are talking about indirect measurement, so parameter will be computed based on the observation that you take in the field, and these observation are primary are, 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 are erroneous, and these error would be nothing but from random error, from systematic error. So we are talking here the small cases, that how the systematic error in ith observation would take part. So it is nothing but summation of 1:n by nothing but the del x by del L multiplied by delta Li. So that's how you see the propagation error of all observation, all systematic, a small systematic error in individual observation would lead to propagated to the parameters. So it's a very basic equation. Please remember that the notation, that here the left hand side is the overall overall non-systematic error, non-random systematic error, or simply non-random error in the parameter would be given by summation of all such cases I is equal to 1 to n by, how do you do it? You know the function, you can take the derivative. Now once you have the derivative, you can multiply it by the corresponding error in the ith observation, if you are aware of it. Okay, so somehow if this is an information which is given to you. Now the curious case is that how you focus on changing between the two. One is this case which we are reading right now on the slide is of the small systematic type errors. Please remember, it is the case we are reading right now, it is a small systematic error. On the next slide, how the errors will propagate, that is of nature, that is of random error nature. So you could see the same function x hat is equal to function of L1, L2, L3, Ln, and in that case you could see from the right hand side it is a square term. However, in the previous case you do not see any square term. To understand this, multiplied by corresponding random error. It is very interesting. You have two cases. Now this is a very beautiful representation that you have two cases. In one case, the error is very simple. It is simple partial derivative multiplied by the amount of error. Here, partial derivative whole square multiplied by error square. So what is the physical significance of it? No, you need to understand the physical significance, because as I've told you, in the case of discussion of the random errors and systematic errors, that in the case of systematic errors, it is generally a cumulation. It is generally a cumulation in terms of if the error is additive, it would additive at all. If it is it is a kind of subtractive in nature, the amount will be subtracted at all. So it is a cumulative positive or cumulative negative. So they have a magnitude which need to be considered. This is very important point. The one you could differentiate between these two equations is by looking at, obviously, with the notation or the sign that you have to follow. In the systematic case, you cannot ignore the sign. However, in the case of random error, the sign doesn't matter at all, because ultimately the function, which is z is equal to x plus y, x minus y, x by y, x into y, whatever it is, you have to just follow the same concept, because you are just working in the square terms. And then we have proven that, isn't it? There is no need to worry about that. We have proven that in the initial few slides. Okay, so the uncorrelated scenario, obviously the reason why we are talking about the uncorrelated nature, because we need to consider here only about the variances of the error. Okay, we are not talking in terms of the covariances of the error, because when we have covariances, we cannot expect them to be represented like that in this manner what we are representing here. Okay, so obviously the representation would change drastically in the sense we would be working more or less with the matrices. Okay, so this you have to be very careful of. If you have any doubt, you can ask anytime. Okay, if you have any questions so far, you can simply ask. I'm just holding a bit. Okay, so if no questions, we can move ahead. So total error, that is nothing but the systematic error. Is there are multiple ways to represent it, and one common ways, one popular ways is that TLI, that is total error in any observation, would be represented by the sum of squares of the errors that are random in nature as well as systematic in nature. Similarly, the error in the parameters would be given by this, and we know the function, isn't it? So the way we are representing it is very simple. Okay, as I've told you, the first two are the very simple cases. The second last one is a very computationally more involved, and sometimes if you open up all these equations, then probably you would see that that derivation would be much more easier to look into. But otherwise, how you represent the total error, if you know their system consists with the systematic as well as random error, you will represent by the top two. That's very good to go kind of scenario. But the third one is obviously representing more involved case, where you have taken into account the total systematic error as well as the individual random errors. Okay, okay, coming back to your little bit derivation, which you should focus on. So you have y as a vector, you have x as another vector, and you have a d, which is the coefficients of constants maybe, or some variables, which doesn't, you need not to worry about. So function is written as y is equal to cx plus d. So if y is equal to cx plus d, what we need to do? We need to first take the expectation on both sides. Now expectation of y would become c expectation of x plus expectation of d. Then obviously, you know, if it is written as expectation of cx, it would be written as c expectation of x, and that's how you mu y would become c mu x plus d. That's very clear. There's no issue at all. Okay. Correspondingly, you have covariances, which is we have to find out how the sigma yy would look like. How would you write sigma yy? It would be written as expectation within bracket y minus mu y and multiplied by y minus mu y transpose. Okay. Now we all know how this works. You just open up, and the first step which you just opening up is cx plus d minus u mu x minus d, because you know the mu x, you know the y. The moment you open it, the take commons out, you get expectation within bracket c x minus mu x, c x minus mu x transpose. When you take c out of this bracket of transpose, the c transpose would come out, and from here you would have c on the left hand side, so you would become c expectation of x minus mu x, x minus mu x transpose, c transpose. So expectation of y would become c sigma xx, c transpose. Okay, it's very simple. You just need to go through from one to last step, the first step to last step. You can see, and very clearly you could identify that the first one, this box, we are talking about the mean of y here. So in this case, we are talking about the mean of y, and here in the second case, we are talking about the sigma y. So please remember, any cases whatsoever would be discussed hereafter would be of the cases of random error propagation. We are not much more focused towards systematic error propagation. We are much more focused towards random error propagation. So all the supporting four boxes, that means here sigma yy, how there is a lot of confusion among students in the last year also, and every time it would be there, because these such contents you are reading for the first time. So what the confusion is, very simple. The confusion is how to write sigma yy, how the sigma yy would look like, how the sigma xx would be represented. So please make sure that you have not only understanding this, you should also understand this part, the sigma yy and sigma xx. The sigma yy is very simple. It is a variance covariance matrix of all y variables, maybe y1, y2, y3, yn. Sigma xx is the variance covariance matrix that is representing variation within x variables. What are the x variables? They are x1, x2, x3, xn. You understand this part? So there are two types of variance covariance matrix that plays the part, that are into the system. One is the input variance covariance matrix, which is sigma xx. The another is output variance covariance matrix, which is sigma yy. Why? Because y is a function of cx plus d. Now you know the x, you will get the y. You understand this part? So if you have two such system, one is sigma yy, another is sigma xx. How to write them, it is very important. How to understand, let's say if I tell you verbally, because we'll take certain question where the verbal content would be given, and you are the one who would be giving the values at the appropriate positions in the variance covariance matrix. Okay, so one is sigma xx, another is sigma yy. So you just don't need to see how it is written. If it is you want me to zoom in a bit, otherwise you can zoom the screen at your end and you could see the content very clearly. If you are in mobile or laptop, please remember you should be having the notebook also, so that this little derivation you should do by your hand, because that's why what happened in the online teaching, the majority of the content is presented. The reason is very simple. sometimes because of the network issues or maybe some other reasons. What happened, if I write everything by hand, it may not appropriately visible at your end. Some of the content would be visible after certain lag. So the whole intensity of the lecture would go missing. So, but there is a drawback also. The course syllabus go very fast and a student cannot participate as such. So, but in the classroom, what we generally do, we generally use these derivation by your own hands. I would like to see your copies also. How you are doing it, because ultimately, if you know the derivation, you do not need to remember anything. If you know the derivation, if you know how to represent the different matrices, different content. Okay, so gradually we are moving towards matrix representation of all those variables which you have read in your only single variables or multiple variables. Here we are talking about n cross n type of matrix, because you cannot have a real world problem in only two variables. The real world problem would be having n variables, and you cannot deal with your small calculators. You have to work on a Python background or a MATLAB background or Octave or anything where you would be comfortable in using those matrices for further operations. So I mean, it's very good that you have such kind of exposure. Please remember these core universities or institute in India it is offering. I am just aware of the two, but maybe three. But this content is very essential in other US universities as well as European universities. And if you find in the syllabus this type of course, okay. So it's very important that you should know how the data and its model is actually playing a part in handling of the errors. Because whenever you present your work to anyone, if you are there in this domain, so whenever you present, just like yesterday I was attending one meeting of our ISRO project. So the committee asked, what is the uncertainty in your data set? So now you see this type of question, and how do you model those uncertainty in the observation into the system? See, this type of question they have asked. Now what is the purpose of asking these question is that if you are aware of the concept, if you are aware about the concept of errors, then you must know that these errors would ultimately reflect in the final result. And if you are able to understand how to represent those errors at initial level, you would be probably representing the right manner the final errors. So it is not about X, it is not about X at all. It is all about how you are representing sigma X and how much magnitude you are working with. Every time up to your BTech maybe, or it is okay to get X, to get the value of X. But in a postgraduate level, in later on in life, it is all about sigma X. So that is very interesting to know. I mean, you would appreciate later on when you work on such a level where magnitude variation of errors is more important than the final value. Okay, so it is equally important that you should have the notebook with you, and because slide is visible for sufficient number of amount of time, you can write it down, you can feel it whether you are following it or not. If you have any query, you can ask. That's how the objective of the course is, okay, to have much more interaction than the learning of in a slide manner. Okay, so this is the covariance of variable y, which is linearly dependent on x. Okay, it's very simple. So I hope you get the slide now. Moving on to the next slide. As I've told you, we are more interested towards non-linear dependent on x, because linearly dependency is very simple. Y is equal to x plus b kind of scenario is very rare, isn't it? you will be always working towards non-linear types of system. And how to do that? So suppose you have a system y is equal to fx, which is which is non-linear, and obviously you know the basic of representing the Taylor series expansion, and a very good representation is given in the slide 1, which is y is equal to fx, and which is a non-linear and would be represented by fx at x is equal to x naught plus del f by del x at x is equal to x naught x minus. This equation you should write. I recommend it that it should be written in your notebook by yourself. The reason is very simple. The moment you write the first equation, you will get enough confidence. Okay, I know how to write the Taylor series expansion. Okay, so y is equal to fx is a non-linear. How to linearize it? The first step, the step 1, rule number 1, you have to choose the initial point. Which would be your initial point? Your initial point would be x naught. See, I'm not opening up how much x is there in terms of variable. It could be n, it could be k, it could be p, it could be t, it could be anything. Okay. So obviously the moment you say x naught, it would be also of the same dimension, isn't it? So if your x is of n variable, your x naught would also be of having n variability. So y is equal to fx means non-linear function with n number of x variable. Okay. Obviously, you have to linearize it with respect to initial point, which is x is equal to x naught. The moment you write it down, fx is equal to fx at x is equal to x. Now we call it as a function value at initial point. Linearization first. Second step is linearization, and the first step of linearization is function value at x is equal to. So what now the confusion part, many times the student has a function value at it, because now it is expected that you should be following it, but sometimes what happened, because your mathematics background is too weak, that sometimes you do not recall how the function values are computed. So let's say y is equal to 2x is there, and you say the initial point is as x is equal to 2. So you will put 2 into 2. The place of x you will put 2, while value would be 4. So that's how I want that the moment you place x is equal to x naught, please remember the capital X represent the vector information. That means it is not only a single x we are talking about, instead it is a vector. That means it would be having n values, k values, anything. So the first step is linearization of first step of linearization is function value at initial point plus partial derivative with respect to all variables individually. So suppose you have 3 variables, you will write del f by del x1 at x is equal to x naught x minus x1, or x1 minus x naught 1, plus del f by del x2 at x is equal to x naught multiplied by x2 minus x2 naught, plus del f by del x3 at x is equal to x naught multiplied by x3 minus x naught. So that's how you try to arrange the different components if it is n variable. Okay, then obviously taking the expectation on both sides. Now you know very well the expectation of constant will be constant, expectation of coefficient multiplied by variable would be coefficient, then expectation operator will go in. So that's how you'll write. You can follow it now. I hope it would not be any problem. Just say it, just try to see it. So at present, I just want to announce also, since it's been around more than around 1 month, maybe we have started the classes. So there are 2 students who are not attending the class regularly. I've just seen from the inside. There's one student called Praveen Kumar, and there is another student called Shreya Goswami, and the third student is Alok Singh. they are not attending the classes regularly. So what will happen? Your stipend will not be released. Okay. So please make sure that you are attending classes regularly. Okay. Just go through the content because everything is just repeated from the previous slide. Only issue is the linearization part, which is additional here. It would be appreciated if you write the content from in your notebook at the same time, because that would give you little confidence that now you are following the content, you know the expectation operator, you know the different variables. Okay. So I'm giving you one small question of you know solving it at your end. There is a very basic question which you can attempt right now. The z is written as 2x1 plus x2. Very basic question. Z is written as 2x1 plus x2. You have to give me the mu z as well as sigma zz. I'm again repeating. The z is given as 2x1 plus x2. Now you have to give me the mu z as well as sigma zz. So anyone with the answer?
Sir, expectation of z equal to 2 mu x plus 1.
Sorry, say again.
So mu z equal to 2 times of mu x plus 1.
नहीं, म्यू एक्स प्लस वन, वन क्यों?
सर इक्वेशन आपने बोली थी ना 2x plus 1 z equal to.
नहीं बेटा, मैंने बोला था 2x1 प्लस x2.
सॉरी सर.
सर
Yes, Alok.
Sir, not done. हेलो.
हाँ बताइए.
सर अभी नहीं हुआ.
ये तो बहुत बेसिक है, इसमें क्या है, कुछ रॉकेट साइंस थोड़ी नहीं है.
क्लियर.
अभिजीत, आप बताइए.
यस सर, स्टार्ट कर रहे हैं.
कब तक करेंगे भाई? बहुत बेसिक क्वेश्चन था यार, इसमें क्या टाइम लग रहा है तुम लोग को?
सर mu z is equal to 2 mu x1 plus mu x2.
ठीक है.
And solving I put it the all the data, but still solving.
So sigma z square, sorry, sigma zz would be how much it is?
So still calculating. 1 minute.
राहुल कुमार.
यस सर.
बताइए.
सर म्यू जेड इज इक्वल टू 2x1 माइनस म्यू एक्स प्लस x2 माइनस म्यू एक्स.
क्या क्या क्या? से अगेन.
सर 2x1 माइनस म्यू एक्स प्लस.
नहीं नहीं नहीं, गलत गलत बता रहे हैं. क्या बता रहे हैं भाई? देखिए, ये प्रॉब्लम आ रही कि नहीं आप लोगों को? Now after looking at the slide for half an hour, you still not able to compute the mu z. See? And you are not asking also. That is the problem. Shubham.
sir. सर नहीं हुआ है अभी.
भाई आप पूछ नहीं रहे, इसका मतलब आपको आ नहीं रहा है, जो पढ़ाया जा रहा है वो समझ में आ रहा है.
यस सर.
यस सर बोलने के बाद आप जवाब नहीं दे पा रहे हैं, ये तो मतलब बहुत खराब बात है. या तो आप आपके हाथ में ना नोटबुक है ना कुछ, आप सीधे मोबाइल लेकर के मूवी की तरह बैठे हैं. क्यों भाई? यशोवर्धन.
Yes, sir.
बताइए.
Sir, mu z equal to 2 mu x1 plus mu x2. तो सर अभी सर सिग्मा z सॉल्व नहीं
क्यों नहीं सॉल्व हो पा रहा, क्यों नहीं हो पा रहा है? क्या प्रॉब्लम आ रही है? प्रॉब्लम बताइए. चलिए, अभी मैट्रिक्स वाला डिफिकल्ट अगर आपको लग रहा है तो आप इस वाले इक्वेशन से करिए. देखिए ये सामने इक्वेशन लिखी है आपके, मैंने चेंज कर दिया है स्लाइड. आप अपने स्लाइड पे जाइए, देखिए. देखिए बहुत बेसिक छोटी सी क्वेश्चन था, उसमें आप लोगों ने 15 मिनट लगा दिए. इससे ये समझ में आ रहा है आप लोग केवल इसे सुन रहे हैं, देख रहे हैं, उसको अप्लाई करने की समझ आप लोग नहीं डेवलप कर पा रहे हैं. वैली शेट्टी, आप बताइए.
Sir,
यस.
sir, earlier I think we solved this same way as a line equation as ax plus b, and the next one z is equal to x plus or minus y. In the same way, if we apply to these two variables as x1 and x2, from the basic thing, if we have any multiple product as k or any variable, for the mu it gets multiplied. And the adding term will be added here for 2x1 and x2, both are variables, so we'll get 2 mu x1 as mu z. We'll get 2 mu x1 plus mu x2, and the 2 will be as same k value. But coming to the variance, the product term will get squared, and the remaining added variable, added constant, will get eradicated. So here there are only two variables, 2x1 plus x2, and the final will get as 4 way of x1 variance plus x2 variance.
Now you see, it is okay in terms of conceptual understanding, but see, you have to write the final variables also. So the moment you are saying variance of x1, there is not variance, it is variance. There is a spelling which is written on this slide which I have just shown. It is variance. So what you are trying to say is the sigma z would be written as 4 sigma x1 square plus sigma x2 square. You get my point?
Yes, sir.
Yes. So it is not variant, it is variance. Okay.
Okay, sir.
How you have computed? The computational is very easy. See, in your case, z is only one. There is not z1, z2, z3, z4.
Yes,
it is only one.
Yes,
Okay.
sir.
There is variable output. Variable is only single, which is z, and it is a function of two variables, which is function of x1 and x2. Okay. So considering this relationship which is written here, what you can do? You can apply this formula. If you are very well understood the concept, you can simply sigma z square would be, because there is no other z2,
Yes,
So
sir.
there is no need to go for matrix because it's a we are talking about only a single variable, isn't it?
Single variable.
Yes, yes, very good. So now how many n are there? Two variables are there. So I would go from 1 to 2.
2. 1,
Okay.
2.
Then sigma z, partial derivative of z with x1 whole square multiplied by sigma x1 square plus partial derivative of z with respect to x2 whole square multiplied by sigma x2 square. तो जब आप
Yes.
ऐसे लिखेंगे तो you will get sigma z square is equal to
4 times.
4. Yes, very good, very good. 4 times sigma x1 square plus sigma
Plus
x2. Very
sigma
good.
x2 square.
Yes, very good. You have explained it also. It's nice.
Thank you, sir.
So I mean, it's way of learning. How do you learn it? Everything is very simple. The moment you have to apply it, the confusion comes there. The difficulties comes there. And you have seen from yourself also, only
Yes,
one
sir.
student attempted it right manner. Okay. Sunil Kumar. क्लास में है कि गायब है?
यस सर।
आपने क्या किया बताइए? बोलिए भाई।
सर नहीं हुआ।
कोई मतलब नहीं आगे बढ़ने का जब आप आधी क्लास बोल ही नहीं पा रही कि कैसे होगा तो कैसे काम चलेगा? अभिजीत, अभी तक आप कर ही रहे हैं कि कुछ हुआ आपसे? अभिजीत, आर यू लिसनिंग?
यस सर यस। हेलो
यस यस स्पीक।
हेलो।
हम्म,
यस सर कर रहा है।
क्या कर रहे हैं भाई? मैं समझ में नहीं आ रहा आप क्या कर रहे हैं, कैसे कर रहे हैं, जरा बताइए, एक्सप्लेन करिए। एक्सप्लेन करिए, म्यूट मत करिए अपने आप को, जब तक बातचीत हो रही म्यूट मत करिए। एक्सप्लेन करिए कैसे कर रहे हैं। क्या डिफिकल्टी आ रही है वो बताइए। अरे भाई बोलेंगे कुछ? आपकी आवाज नहीं आ रही है।
सर ट्राई कर रहे हैं।
कैसे ट्राई कर रहे हो वही तो मैं जानना चाह रहा हूँ। Your sincerity level is a question mark. अरुण कुमार साहनी।
यस सर।
बताइए।
सर नहीं हो रहा है, ऐसे कर रहे हैं।
क्यों नहीं हो रहा है? मुझे समझ में नहीं आ रहा है। व्हाट इज सो डिफिकल्ट इन इट? इट्स वेरी सिंपल। we are moving towards advanced level, and still you are not able to solve very basic 2-3 steps which are involved. Okay, raise your hand in your teams if you want to, from my side to explain it again, how to move ahead. I just want to see how many people are not able to get this basic solution for this. Just raise your hand. Okay. So it's very basic. First of all, you need to understand. Let me just again tell you from very basic background. You just need to see the question, what type of model it is given. So I've just asked you, there is a model which is called as Z is equal to 2x1 plus x2. This is the model. Z is equal to 2x1 plus x2. You need to understand 2 points very clearly, that on the left hand side you have Z, which is considered as an indirect observation. On the right hand side you have x1 and x2, which are considered as a direct observation. Obviously you are doing, or you are using x1 and x2 to compute Z. Fair enough? On the right hand side you have to first think how many variables are involved. So here only 2 variables are involved, which is x1 and x2. That's fine. On the left hand side, how many variables would be computed? Only one, which is Z. Clear? Now, in order to take on the problems, one is asked as what is mu Z? I have asked what is mu Z, and another is sigma ZZ. Okay. So obviously I am interested in what is mu Z. So you, for computation of mean of Z, what I've just told you, take the expectation on both sides. This is the first step towards finding out the mean of Z. Take the expectation on the both side. The moment you take expectation of Z, it would become mu Z. The moment you take expectation of 2x1 plus x2, it is an addition. Expectation of a plus b would be expectation of a plus expectation of b. Now, expectation of a would become expectation of 2x1 plus expectation of x2. Now 2 is multiplied to x1, 2 would come out and would become 2 of expectation of x1 plus expectation of x2. Expectation of x1 would become mu x1, expectation of x2 would become mu x2. So answer would become mu z is equal to 2 mu x1 plus mu x2. That is the very basic and fundamentally you have solved for so-called mean. The second question is about the sigma ZZ, which I have asked about the variance in covariance. So please understand, you have only one output variable. There would be no chances of covariances. Covariances would only occur if you have more than one variable. So in finally, you have only one variable, one output variable. So therefore, it would be simply written by sigma Z square, the small sigma Z square. Don't confuse it with the capital sigma. It is a small sigma Z square is equal to, now I've told you in the case of error propagation for two cases, systematic and random. Now you can look at your screen right now. I hope all of you would be looking at this slide of law of propagation of random error or propagation of variances. So in this case, since it is a single variable, so the left hand side would become sigma Z square. The right hand side is, obviously, it is a two variables are involved. So variances of two variables would take into the part, and the summation I is equal to 1 to n, so n would become 2 because there are only two variables, x1 and x2, and obviously followed by partial derivative of z with respect to x1 whole square multiplied by sigma x1 square, okay, plus partial derivative of z with respect to x2 whole square multiplied by sigma x2 square. You need to understand this part very clearly since there are two variables involved, okay. So sigma z square would become 4 x1 is sigma x1 square plus sigma x2 square. Why? Because del z by del x1 would give 2 as a final answer, and it whole square becomes 4. So it is 4 sigma x1 square plus there would be no coefficient with x2, it would become 1 whole square multiplied by sigma x2 square. Now, is it clear or not? Parul, you get the final solution or not?
Yes, sir.
Yashovardhan, are you able to concentrate on it or not?
Yes, sir.
Abhijit,
Yes, sir.
Sunil,
Yes, sir.
Alok,
Yes, sir.
तो चलिए फिर नेक्स्ट प्रॉब्लम सॉल्व करिए, अपने हैंड्स जो रेज किए हुए हैं उन्हें लोअर करिए। चलिए नेक्स्ट प्रॉब्लम करिए। Z1 इज इक्वल टू, लिखिए, Z1 इज इक्वल टू 2x1 प्लस x2, बहुत सिंपल तरीके से आपको बता रहा है। Z1 इज इक्वल टू 2x1 प्लस x2 एंड Z2 इज इक्वल टू x1 प्लस 2x2। In last problem we have only Z. Here we have Z1 and Z2. Basic concept will remain same. There is no need to be worry about this. There are two variables, how to do it. Very basic concept. Z1 is equal to 2x1 plus x2. I hope you have written it. Z2 is equal to x1 plus 2x2. Now you need to give me mu z as well as sigma zz. इस वाले केस में आपको जैकोबियन का यूज करना पड़ेगा, जो कि आपके सामने ये लिखा हुआ है। फर्स्ट यू नीड टू arrange these two equation into a form of y is equal to ax plus b or d, whatever it is. If it is not, it would be considered as 0. So a big Z would be equal to capital A into x. Now this is your function. If it is clearly to go ahead, because now you are aware from this equation So from this equation, it is very clear. From this slide, it's in fact the slide in front of you. It's very clear that if a function is written like y is equal to cx plus d, the sigma yy would be c sigma xx c transpose. Okay. So first you need to form y is equal to cx. If it is formed, then you can have easily computed these sigma yy is equal to c sigma xx c transpose. So in your case, it would be z is equal to cx or z is equal to ax or whatever it is. First need to clearly identify what is x, what is z, I mean capital Z, capital X, how many vectors involved, how many variables involved in both cases. And if you're able to write it properly, then it is very easy to get the final sigma zz as c sigma xx c transpose. A little practice would make the difference with all of you. Just little practice. If you practice it enough in order to get to the slide, I'll just upload today so that you could focus on the content. Just a little practice would make you much better in terms of answering it. See, the reason is very simple. You are not very much equipped with your basic mathematics operation right now. That is why you are not able to solve it properly. Okay, but you can attempt it obviously with your little skills for which you need a practice. Focused रहिए, जो भी if in a single doubt is there, you should immediately ask. Now, if anyone has attempted it and want to share the answer, just share it. Anyone with the answer?
Sir, sir, am I audible?
Yes, you are audible.
Sir, here you have given us two variables and z1, z2 with the parameters 2x1 plus x2 and second one x1 plus x2, and there are no constants. So if we frame into the matrix form as z is equals to ax or some variable kx, that A will be as matrix of 2 1 and 1 2. For this, if we will get a mu z as A mu x. But coming to sigma yy, I'm somewhat confusing, sir. That A matrix will be as it is A and A transpose, and sigma zz will become as A into sigma xx into A transpose. The sigma xx matrix, I'm somewhat confusing, sir.
Yeah, so here what need to understand, I think my screen is not shared. Let me share it again. See, so you have the C as a matrix 2 cross 2.
Sir.
You have C transpose at 2 cross 2. What you need? Sigma xx. If you do not know sigma xx, you cannot solve it, isn't it?
Yes,
But
sir.
how the sigma xx is written, you can see it from this slide.
Yes, sir. Variance of x1, x11 and x1, x2.
Yes, sigma x1 square, sigma x2 square. Since only two variables are involved, you will write it as sigma x1 square, sigma x2 square, and on the diagonal element you will write sigma x1 x2 and sigma x2 x1. For this particular case, I am saying both are uncorrelated. They are not correlated. So obviously the diagonal element, non-diagonal element would become 0.
Yes.
So it would become only sigma x1 square and sigma x2 square. You write it down in place of sigma xx and you can multiply it to get the solution, because you have the C or A, whatever you have, and you have the C transpose.
The A and A transpose will be of same because they are symmetric matrices, sir.
And why it would be same? 2 1 1 2. That's why.
2 1 1 2. If we transpose also, we'll get the same matrices.
Yes, true. That's because of this example. You may consider like that. Maybe
Yes,
in
sir.
another case it would not be the case.
Yes, sir. Only for the example what you have given, I'm saying that
Yes.
is a symmetric matrix.
Yeah. Yes.
Sir, after this mathematical calculation of sigma zz as A into sigma xx A transpose, finally I got the matrix as 4 sigma x1 square, that matrix of sigma zz of first term 1 term 4 sigma x1 square plus sigma x2 square, and second 1 2 term z12 term 2 sigma x1 square plus 2 sigma x2 square, and next variance of z2 z1, the third term as 2 sigma x1 square plus 2 sigma x2 square, and next final z2 square term sigma x1 square plus 4 sigma x2 square.
Sir, I got the same thing.
Sir, voice is not coming. Sir, voice is not coming.
So I think I was not audible for quite a long time. I could not see your messages also. So what I'm trying to give you a problem here. I hope it is audible now. Sumit, you haven't informed me.
Sir, Sunil was speaking already, sir, that voice is not coming. I thought you would have heard.
No, nothing came to my end.
Actually, Sunil 2 times informed that voice is not coming.
Anyways, so uh, this problem of finding this solution for XP and YP is given here. One is you have this origin whose coordinate is known without any error. It's error free, x naught, y naught. You have two observation. One is this angle from north. This is the distance d. Now what you need to do, these are the observation values which I have written along with their variances. Then you have to find out the coordinate for XP and YP. So first you need to write the mathematical model for it. Okay. And then you have to tell us about the final variances in those data set, in those final values. So what you need to do, you need to first tell me the mathematical model. Okay. What could be the mathematical model for it? So mathematical model आप बताइए XP and YP, how it would be estimated. If you know the mathematical model, you can find it out, the values of XP and YP. Okay. So basic trigonometrical relationship which you have to work it out. बताइए वैली शेट्टी, आप बताइए.
Sir, I didn't get clearly, sir.
Anyone else?
Sir, we use the coordinate system distance distance between two coordinate system. Hello?
In the case of distance between two coordinate system, the angle information would be left out.
Not. Yes, sir. That was I thinking.
That would not be possible. You have to make a function like this.
X component of
Yes, speak, whosoever it is.
sir, we can take X component and Y component of distance d, assuming X naught Y naught as origin.
Mm-hmm. So how would you write XP?
By using Pythagoras, sir.
No, again with Pythagoras, what Pythagoras theorem tells you? Just open it up.
So if we have X component and Y component is square under root, then we will get d. We will
But again, the angle information is missing. That's what I'm telling you. You have to make a function like this. Then only the two information would come.
Sir,
Yes.
sir, XP equal to X naught plus D sin theta, sir, लिख सकते हैं sir.
Good. सही है.
And YP is equal to Y naught plus D cos theta.
See? Very good. Right. Very clearly you have explained it. It's very simple. Now you know x naught and y naught. Moving ahead to any point, you need these two in vector. Now you have this vector x naught is this position, sorry, xp yp. Any position of xp and any position of xp yp would be adding up this origin information x naught y naught plus the corresponding this length. This length would be given by the trigonometrical relationship. So now you have this function which is xp is equal to x naught d sine theta and yp is equal to y naught d sine theta. Now what you have this kind of observation, isn't it, where you have certain constant and the variable which is multiplied in nature. So how would you find the xp? Just by putting the value of d and theta. How would you find the yp? Just putting the value of d and theta. So your xp would come somewhere around 600 meter and yp would come around somewhere around 873.2 meter. So that's how you compute xp and yp. But that is not my question. My question is how would you compute the associated sigma xp square, sigma yp square? So considering this is as a non-linear model because this is the d sine theta, d cos theta. These are all non-linear functions. So for non-linear function, if you quickly go through your notes, the sigma yy is nothing but Jacobian sigma xx Jacobian transport. This is for non-linear case. For linear case, sigma yy was c sigma xx c transpose, isn't it? And we have solved cases for C transpose. Now this is the case of Jacobian. So in the case of Jacobian, you know what is Jacobian is? Jacobian is nothing but partial derivative of function with respect to variable. So first you need to understand what is your sigma xx in this case. Sigma xx would be nothing but sigma d square, sigma theta square. Assuming these they are non-correlated or uncorrelated case. Okay. Now what would be your Jacobian? Form your Jacobian. Jacobians are in this direction you have function, in this direction you go with the variable, number of variable, dimension, number of variable, and here number of function. So first del f1 by del x1, del f1 by del x2, del f1 by del x3. See, we are moving in terms of number of variables. Here, next line, del f2 by del x1, del f3 by del x1. So here we are moving in terms of function. The Jacobian which you have to prepare is nothing but del of xp with respect to del d, del of xp with respect to del theta. Similarly, del of yp with respect to del d, del of yp with respect to del theta, because you have written function like these. One is xp, another is yp. So there are two functions, xp, yp, two variables, d and theta. So when you take the partial derivative, obviously you will have certain values. Let's say if you take a partial derivative of del x with del d, you would get sine beta. Del x with del theta, d cos, uh, theta, d cos theta. Similarly, del yp by del cos theta, and then minus d sine theta. These are the partial. We have to compute at the given d and theta. तो values of d and theta आप insert कर दीजिए, you will get the final Jacobian. This all four values can be computed for inserting the d value, theta value. You all know because I've given in the observation the d value is 200 meter, theta value 30 degree. Because the moment you do it, you will get the Jacobi. Now, the sigma yy, which is nothing but sigma xpyp, would be given as Jacobian sigma xx Jacobian transpose. Now your J is coming here, J transpose would go there, and sigma xx you have computed, or in fact it is given as sigma d square sigma theta square. Answer would be available. See, I have just followed the steps. I have not done any rocket science, just step-wise step information. So I expect that you people would give me the solution for this problem. It's very simple. Again, start from very basic. The problem is, again, I'm just explaining to you. You can do it without looking at solution. This is the formula. This is the problem representation. You have to find out the position of xp and yp. You have given observation d and theta. You have to make mathematical model such that it would be function of d and theta. Then xp would become function of d theta, yp would become function of d theta, and then you have final values. See, this is the point where you need to step in with your practice. The more you do the practice, the more you, in your mind, you can think of problems. The basic problem, the basic equation, linear thermal expansion equation, this such type of equation of trigonometrical relation where you consider that variables from linear measurement and angular measurement would come, and just simply write the mathematical model. If you are able to write the mathematical model, the rest is very simple. You have to take one by one. If it is a linear case, it is a single variable case, multi-variable case, non-linear case. So just take it step by step. First, you need to think how many output variable are there. One, a simple formula that I've shown you. Single dimension problem can be easily tackled, no issues. If it is a multiple, it is a linear model or non-linear model. If it is a linear model, your y is equal to x plus b can be easily written. If it is a non-linear model, you have to form the Jacobian. So obviously, non-linear model, you are in such a level at a PG level. Do not consider yourself as a very early entry level. You are a PG level student, so you need to think in that direction. First, problem of non-linear would be coming more frequently rather than the linear one. Okay. So I think we are reaching the right time. So we'll stop here. We'll meet you on Thursday. And at the time you need to focus on revisiting these lectures. In fact, today's lecture you need to revisit again. You can download the recording, or you can just simply go through the lecture once again and try to focus on the how do you implement the mathematical model, how do you write the mathematical model, how do you learn about linear and non-linear cases, how would you see about single variable, multiple variable case, and are you able to follow this concepts which we are discussing here.